Does it default to turn left? If all other things are equal, and there's something in its way?
Forget how I made it.
It seems like it, but could be.
I think if it's just front. I think if it's just the front object, it turns left.
Okay, yeah.
Right in the center. That's good.
It's
Slight
actually,
miss.
Yeah, it's just slightly missing, that's all.
yeah, I think it's because this thing's
Yeah.
out pointed down slightly. So.
Yeah.
There.
Slight miss again.
Oh, it's right under the shirt. That's why we're not seeing it. It's
Okay. It's bound to not actually hit the center, even if that's not, you know.
But it moved. There.
Good one.
Okay.
That's good.
Throw it right over there. Oh yeah, it doesn't search when it's
Yeah. Turning.
Turning.
Yeah, it's something else we have to.
That makes all of this make more sense.
Okay.
So this is SniperBot. It's a project by Christian Renner, David Taylor, and myself, Michael Giuliano. It's an autonomous robot that uses both a Raspberry Pi and an Arduino to control it. It performs color detection using a USB camera right here, and it uses ultrasonic sensors, one on either side and one on the front, to detect objects so it doesn't crash into things. Here's a picture of it right here, and it has a laser up here for the weapon that it shoots. That's just a basic laser pointer. Here is all those. Here's the Arduino and all the wires connecting everything. Underneath this wooden platform here is where the Raspberry Pi is. Here's a speaker that it uses when it shoots the laser. It makes a ticking sound with the speaker. And that's pretty much it. Now for the code. We have several files here. We have a color detector class that we wrote. Here we have some error codes, default window width, some color code constants, video capture object, and some other things. Here the get screen size, it just gets the size of, it grabs an image from the camera and then determines the size of it, the width and height. Here's a constructor, takes several arguments and a bunch of get and set methods for the properties. And then here's the main function here, the find color from cam. That actually grabs a screen capture from the webcam, analyzes it, and tries to find a specific color, blobs of a specific color. And if it finds it, it returns the X and Y coordinates through these reference variables here. So that's that class. Well, that's the header file, and then the actual source is right here. Have all the get and set methods, and then the find color from cam method. Does all kinds of stuff. Then we have a GPIO class. This we actually found online. We didn't actually write this, but I did add some commenting for the project. Basically, the Raspberry Pi has what are called GPIO pins, which stands for General Purpose Input Output, and you basically set them high or low, and then connect wires to them and connect them. We have them connected into the Arduino, so that the Arduino and the Raspberry Pi actually communicate back and forth. Basically, the main brain of the robot is run on the Raspberry Pi, and it sends commands to the Arduino, which controls the motors, all the servo motors, the laser, and all the sensors. So this is a class that we use to set up all the GPIO communication between the two boards. Again, like I said, we didn't actually write this. We just added some comments for the documentation. And then here is our main program. This actually runs on the Raspberry Pi. This is the main brain of the robot. We have a bunch of command constants. So these are the values that the Raspberry Pi will send through a couple wires to the Arduino to tell it what to do, to move the motors forward, to go backwards, turn left, right, to move the camera up, down, left, right, start firing, stop firing, center the camera. And here are some state variables for the constants, rather, for the robot state. Here's some GPIO variables. What else the color detection objects from our class that we wrote. Here's a video capture. I forgot to mention we used a third-party library called OpenCV. It has thousands and thousands of algorithms for different kind of object detection, color detection, face detection, depth perception, all kinds of stuff. We just use the color detection part, but video capture object is what we use to grab an image from the camera. That's part of the OpenCV library. Here's a send command method. That's what it uses to send one of these command constants up here to the Arduino. And below that we have, here's just some method we wrote. There was no, we wanted to pause the program for milliseconds, but there's no millisecond pause function. There was either a second pause, took a number of seconds as a parameter, or it took number of microseconds. We wanted milliseconds, so I wrote a function just to sleep for a certain number of milliseconds. Then we have the setup GPIO. This sets all the GPIO pins up. And setup camera creates the camera object, and it creates a target area object. Then we have get ultrasonic states. So the Arduino constantly checks the 3 ultrasonic sensors for objects within a certain threshold distance, and it sets a pin high or low if it finds an object, and then it's also connected from the Arduino to the Raspberry Pi, and the Raspberry Pi reads these pins to see if there is an object or not. So that's what that does. And then here's the our main function. Sets up the GPIO, sets up the camera, make sure the camera setup worked, And it starts off by moving the robot forward and setting its state to searching. And here's the main logic loop. So it starts off, gets the ultrasonic sensor states, and then it tests to see if there's any objects, and if there are, it turns out of the way and goes a different direction. Fine. Here's where it calls the find color from camera from our color detector class, and gets the X and Y. And here it's testing if there's no object detected. Oh, I'm sorry, if there is an object detected in the camera, then it sets a state to targeting and stops moving and starts zoning in on the target. There's some just movement parts. And here, if it's targeting, it grabs another screen capture. And here it actually moves the camera to try to center the target in the camera's view. And once it's centered, it sends the start firing command. If it can't see the target anymore, then it stops firing. And that's it for that. And then over to the Arduino code. Here's the Arduino code. So we have the command constants again. Some other constants. There's a lot of constants. And then here's a pin information, just saying what number pin is associated with what. Some more pins. This sets up the servos for moving the wheels and the camera. Ultrasonic sensor pins. And here's the setup function of the Arduino. This is the first thing to run. It sets up the pins, it sets up the servos, and enables interrupts, which I'm not going to go into that, but interrupts actually executes the command. It looks at the command and executes it. And then here's the main loop. There's a loop function in every Arduino program. So it starts, I'll ignore this line, I put this in after the fact. But here it checks for collisions. If it's firing, then it starts turning the laser on and off and playing a tone through the speaker. And then here's the our check collision function. So get ultrasonic distance. It measures the distance using the ultrasonic sensors. And here's the interrupt that I was talking about, handle command. Here it gets the command, and based on what the command is, it'll do whatever it tells it to do. And here that interrupt uses this to get the command, it gets the information that the Raspberry Pi sent it. And here's a bunch of movement functions: stop, rotate left, rotate right, move forward, a bunch of stuff, move backwards, and that's it.